afternoon, all of you. In today's session of class 12 chemistry, we are going to continue with the chapter solutions. Now, in today's session, we are going to start one topic that is called osmotic pressure. Okay, so basically what happens is that suppose you have a solution. Okay, suppose you have a solution, so it has got a solvent and a solute, and let us say that it is surrounded on all sides by a solvent, and you have the separation between the solution and the solvent is by a semi-permeable membrane. Semi-permeable membrane is usually parchment paper, animal bladder. These are all examples of semi-permeable membrane. So, like I said, you have a solution like solute plus solvent, and it is separated from solvent by a semi-permeable membrane. So, there is a phenomenon known as osmosis. So in osmosis, what happens is that the solvent seeps into the solution. So it's like the place where you have more of solvent to the place where you have less concentration of solvent. So that is known as osmosis. So osmosis is the seepage from solvent into the solution. That is called osmosis. Now, suppose you want to prevent the osmosis, suppose you want to prevent the passage of solvent into the solution through semi-permeable membrane. So if you want to prevent it, then you will have to apply some excess pressure over here. So that excess pressure is known as osmotic pressure. So osmotic pressure is the excess pressure that you must apply on the solution side to prevent any osmosis into the solution from the solvent side. So that excess pressure which you have to apply, that is known as osmotic pressure, right? So the scientist who did research on osmotic pressure, so his name was Van Hoff, VAN''T''HOFF. So what Van Hoff said was that the formula for osmotic pressure. So according to Van Hoff, the formula for osmotic pressure, like pi is the symbol for osmotic pressure. So pi is equal to C into R into T. So C is the concentration of the solution. This is pure solvent. Okay. C is the concentration of the solution. Concentration means moles per liter. So concentration will generally be in moles per liter into R. So R is the ideal gas constant into T. T is the Kelvin temperature. So according to the scientist Van Hoff, the osmotic pressure symbol is pi. The osmotic pressure symbol is pi. So that is equal to C. C is the molarity of the solution or concentration of the solution in moles per liter into the universal gas constant R into the Kelvin temperature. So this is the formula to find the osmotic pressure, right? Now, as you may have understood that osmotic pressure basically depends on the concentration. So if you have two solutions with you, let's say A and B, and the concentration of A is more, so A is called hypertonic and B is called hypotonic, right? So if you have two solutions A and B, right, and the concentration of A is greater than B, then A is called hypertonic and B is called hypotonic. Suppose if you have two solutions A and B with same concentration, then they are called isotonic, right? So in case of hypertonic solution, it has a greater concentration, hypo has a lesser concentration. If they have the same concentration, they are called isotonic. So what is the use of all this? Well, if you separate A and B by a semi-permeable membrane, then obviously the seepage osmosis will be from the hypotonic to the hypertonic. If they are both isotonic, there won't be any osmosis at all, right? So we have just started this topic today, osmotic pressure. And by the way, why are we doing this topic in this chapter? Because osmotic pressure is a colligative property. Okay, osmotic pressure is a colligative property. That means it depends on the concentration of the particular solution and does not really depend on the nature of the solute, right? So this was the topic for today, osmotic pressure, and now based on this I will give you the usual number. Okay, so basically these are the three homework questions from osmotic pressure. The first homework question is that 3.42 grams of sucrose is there in every liter of solution. Right, there is a solution of sucrose which has 3.42 gram of sucrose per liter of solution. The molar mass of sucrose is 342 grams per mole and gas constant is 0.083 bar liter per mole Kelvin. So you have to find the osmotic pressure, right? So you have to find the osmotic pressure of 3.42 gram sucrose per liter of solution. Molar mass of sucrose is 342 gram per mole. R is 0.083 liter bar per mole Kelvin. Question number 2. In 100 cc of solution, you have 3.002 gram of solute and osmotic pressure is 2.55 atmosphere. So what is the molar mass of the solute? Gas constant is 0.082 liter atmosphere per mole Kelvin. Question number 3. 13.5 gram of urea is dissolved in every 500 ml of solution in water and that is isotonic with sucrose in water. But we don't know the concentration of sucrose, so the question is calculate the mass of sucrose in 500 ml of solution. So I repeat again the third question. 13.5 grams of urea is present per 500 ml of solution in water and that is isotonic with sucrose in water. So what is the mass of sucrose in 500 ml of solution? So these are the three homework questions based on osmotic pressure, and as usual you can complete your homework by 9 p.m. tomorrow. That will be all. Bye all of you.